Our 7th lecture video on force will cover the basics of gravity and weight. The weight of an object is the amount of gravitational pull exerted on an object by Earth or another planet. We won't go too much into the details, but the gravitational pull exerted by the Earth is much greater than the gravitational pull exerted by the Moon, since the Earth is much more massive than the Moon. If there's an unbalanced force, which means the net force acting on an object is not equal to zero, according to Newton's second law of motion, there will be an acceleration of the object. As an example, say you hold an apple in your hand. When you are holding it in your hand, the forces are balanced so the apple doesn't move. If you let the apple go or remove your hand from underneath it, the forces acting on the apple are unbalanced and the apple will start accelerating down towards the ground. The weight of an object is really just the force exerted on the object by the Earth or some other planet, and it gives the object an acceleration of g, which is the acceleration due to gravity. Since weight is actually a force, we will use a capital F sub W to represent the weight force, and this is equal to the mass of the object multiplied by g, which is the acceleration due to gravity. This is essentially another form of Newton's second law, which states that force equals mass multiplied by acceleration. The acceleration of gravity g is a constant that depends on which planet you are on. On Earth, g equals 9.80 meters per second squared or 32.2 feet per second squared, depending on which system of units we are in. It is very important to note that mass and weight are not the same thing, which we can see from the formula on the previous page. The mass of an object remains constant because it is simply a measure of the amount of stuff that makes up the object. If we have an astronaut on Earth, let's say their mass is 135 kilograms. The mass of that astronaut will also be 135 kilograms on the Moon because the astronaut isn't changing size when they go from the Earth to the Moon. On the other hand, the weight of an object varies according to the gravitational pull acting on the object. Therefore, the weight of this same astronaut is 1,320 newtons on Earth, but on the Moon their weight is only 220 newtons. Remember, their weight will change because weight is a measure of the amount of gravitational pull exerted on an object. Let's take a look at an example of a weight calculation. Find an 85.0 kilogram astronaut's weight on Earth. Then find his weight on the Moon, where the acceleration due to gravity g equals 1.63 meters per second squared. Before we jump into this problem, let's write down the information we were given. We know that the acceleration due to gravity on Earth is 9.80 meters per second squared. On the Moon, the acceleration due to gravity is 1.63 meters per second squared. The mass of the astronaut, which does not change based on their location, is 85.0 kilograms. We are trying to find their weight on Earth and their weight on the Moon. The basic equation that we can use for both calculations is that the weight force is equal to mass times the acceleration due to gravity. Since this equation is written in terms of weight force, we don't need to find a working equation. We can go directly to the substitution step. When we substitute, we have the weight force equal to 85 kilograms times 9.80 meters per second squared. This means that the astronaut weight is approximately 833 newtons on Earth. In case you were wondering, that is about 187 pounds. Now we can find the astronaut's weight on the Moon. To do that, we will take 85.0 kilograms and multiply that by 1.63 meters per second squared. This gives us a weight on the Moon of 139 newtons, which is roughly 31 pounds. This concludes our discussion of mass, weight, and gravity.